What's up everybody, welcome to Midiverse TV. Today we're going to be talking about a DIY synthesizer module that we recently finished building. This is a Barton Musical Circuits Single Multiplier / Divider module. So what this module does is you give it a clock signal and then it will either multiply or divide that signal. So you see the input there, that's where you put the clock signal, and then the output that will give you the multiplied or divided clock signal. And then there's also a reset that will reset whenever you feed it a gate, so that will get your divisions back on the downbeat or something like that if you're using it with another sequencer. So what we're doing here is we're going to take the sync output from our MIDI to CV converter and make a copy of it, and we're going to send one of the copies to a Barton analog drum module so we can hear the clock, and then we're going to send another copy of it to the Barton Single Multiplier / Divider module. That's the module we're talking about today. And then we're going to take the output of that and run it to another Barton analog drum module. So this way we'll be able to hear what the clock signal is, and we'll also be able to hear the divided clock signal or multiplied clock signal. And then the last patch cable we got there is a reset. That way, whenever we push play on our MPC 1000, the sequencer will be reset on the downbeat. Okay, so this is drum number 1 here, and as you hear, this is the clock signal that is being sent out of the MIDI to CV converter. So that's the same signal that's going into the module here, and here is that signal divided by 16, here's divided by 8, divided by 4, divided by 2, times 1, so that's the standard clock, times 2, and then times 4. So we'll go ahead and play around with these controls manually here just for a moment. The lower pitched drum is the clock and the higher pitched drum is the divided clock or multiplied clock. Okay, so the last thing we're going to take a look at here is the CV input. So the CV input has an attenuator tied to it so we can control the amount of control voltage. So we're going to take a triangle wave from our LFO just down below it there and run that into the CV input. And then as we increase the attenuator, you'll hear the division or multiplication value change based on the rate of the LFO. Thanks for watching this episode of Midiverse TV. Feel free to check out our website at midiversetv.blogspot.com and also add us on Twitter at Midiverse_TV. Thanks. Peace.